Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 2.7 from the C programming language textbook by Kernighan and Ritchie. Now, exercise 2.7 says to write a function invert that returns x with n bits that begin at position p inverted. So ones are changed into zeros and zeros into one. And we have to leave all the other bits unchanged. So here I have a small function just to test this. And just to make sure we understand what this means, suppose we have this binary or this number expressed in binary, and we have position p starting at where the cursor is, and we have n equal to 3. So we need to flip this 0 to a 1, this one to a 0, and this one to a 0 also. And so we should get this as our result after we run the function. So let's actually implement the function. Now, before we do that, let's think about how we might go about doing this. We might be tempted to use this negation operator, but we should only negate the specific bits. So here is the exclusive OR operator, and here's a truth table for it. And one thing to notice is when we have 1, so here we have 1, regardless of what we, regardless of what the other operand is, so if 1 exclusively ORed with 0, or 1 exclusively ORed with 1, in either case, what we have here is flipped. So this 0 is flipped and this 1 is flipped. So exclusive OR, when ANDed with a 1, will flip the bit. However, when it's a 0, regardless of what you do, what the other operand is, if you do 0 exclusively OR with 0, you still get 0. And 0 exclusively ORed with 1, you still get 1. So the nice thing is here, what we can notice is, when you do an exclusive OR with a 1, it will flip whatever the other bit is. When you do an exclusive OR with a 0, it will keep the other bit the same. So generally, what we should try to do is try and, like for example here, we should try and have a binary digit that is 0, 0, 1, 1, 1, 0, 0, 0. And then if we exclusively OR these two things together, this answer is what we will get. So let's do that. So the first thing we need to do is get this 0, 0, 0, 1, 1, 1, 0, 0, 0, 0. How can we do that? Well, we'll first create an unsigned integer, and I'm going to call it flip bits. And this is going to help us flip the bits. So if I take the negation of 0, that's just a bunch of 1s. If I shift it by n positions, that leaves everything with 1 except the final n bits will be 0. And then if I negate that, then I have zeros everywhere except for the final n bits. Now I want those final n bits that are 1 to be shifted in the place of those bits that we want to flip. So I'll shift it to the right with this, p minus n bits. Now I should OR do the exclusive OR with this value and my actual digit x. So I'm going to say x should now be equal to x exclusively ORed with the flip bits. And then I should return x. Now, if this works okay, this function here, this main function, should print out the value of 103. So let's see. I'm going to compile this. Okay, that works all right, no errors. And let's see, 2-7, 103. So we've successfully flipped the bits in the position that was required. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye-bye.